Okay, this video we're going to be looking at velocity and other rates of change. So the first thing we need to talk about is just really getting into what a derivative is. Okay, basically we know derivatives are slopes of tangent lines, but in the big conceptual world they give the rates at which things change in the world. Give the rate at which things change in the world. There's lots of things that change in the world. So we can look at growth. We could look at trees and how the growth ring changes over time. We could look at medication and the amount of drugs and the dosage that affects how a body is going to respond to a drug. We could look at how a particle moves in space. We could look at area with respect to the radius. We could look at the economy and how that changes over time. We could look at a business perspective if you were producing steel and how much money you make profit versus how many tons of steel you produced. So as we can see, there's a lot of applications and a lot of needs for derivatives, whether it's in medicine or in the economy or measuring growth. So we have a lot of ways we can use derivatives, and that's why calculus was created in order to solve these types of situations. Okay, so when we get back to, right now I'm going to go through and I'm going to summarize all of the different applications of derivatives and the formulas that exist. All right, so first we're going to start off with our difference quotient. We have seen this formula over and over again. Okay, we know the difference quotient if we look at our f of x plus h minus f at x all over h. Okay, we know that this is our average rate of change. Okay, and we spent quite a bit of time looking at that. Then we moved into instantaneous rate of change. Okay. When we look at instantaneous rate of change, let's talk about, we have f with respect to x at a. Okay, and we know that the derivative is equal to the limit as h approaches 0 of f of a plus h minus f at a over h. So basically, anytime we talk about rate of change, we may not include the word instantaneous, but we're always referring to instantaneous rate of change. So if you ever find the rate of change, it's saying find the instantaneous rate of change, which is also saying find the derivative. Okay, so now we're going to talk a little bit about a little bit more simplistic idea of just what displacement is. Displacement is simply an object moving along an axis. Object along a coordinate. Along an axis, excuse me. And it could be something like the s-axis, s-axis. Okay, so we're going to be starting at time t, and then we're going to take time t and change it by a little bit. So we've got time t over delta t. So we're just taking an object and we're moving it, and it can move right and then left and goes back. And we can say that it's going to move according to the function f at t. Okay, so what we can say is our displacement is simply our change in s. And we're going to just evaluate the function at t plus delta t, and then we're going to subtract f at t. Okay, so to calculate displacement, we'll do some examples in the next video, but displacement is just simply your function evaluated at one of the times minus the function evaluated at the other time. Okay, so so far, just to review, we've talked about the difference quotient, which led us into instantaneous rate of change. And then we're going to backtrack for a little bit, and we talked about displacement. Now, how does displacement connect to derivatives? Well, average velocity is calculated as displacement over time. Okay, so basically your displacement formula was F at t plus delta t minus F at t all over delta t. Okay, so this should look very familiar to you. Here is your difference quotient. Okay, so basically velocity is simply the derivative of your initial function. Okay, and then that is also equal to the limit as h approaches 0 of f of t plus delta t minus f at t, okay, all over t. Okay, so simply velocity is equal to s prime of t. All right, in the next video, I'm going to do a really short video. We're just going to summarize and make one summary sheet of all these ideas. Okay, so we know what velocity is. So again, going back, we started with the difference quotient. We went to here. We went to what instantaneous rate of change is. Then we looked at displacement. And now we see how average velocity is simply displacement divided by time. So velocity is your derivative of your initial distance function. Okay, now we're going to talk about what speed is. Okay, speed, basically particles that are moving to the right have positive velocity. Particles moving to the left have negative velocity. So that's the way to describe particle motion, is by looking at whether it's positive or negative. However, when we're talking about speed, it is always a positive value. So speed is always the absolute value of velocity, or speed is the absolute value of your distance function.